Hello, this is Mrs. Ross, and this is Lesson 10, Writing Division Answers as Mixed Numbers. That's a whole number and a fraction. And then we're going to do some improper fraction problems as well. Those are when the numerator, or the top number, is larger than the denominator, which is the bottom number. These are the starred problems from Lesson 10, and you'll find them on page 70 of your Saxon Course 2 book. Let's get started. All right. Number 2 says use the words perpendicular and parallel to complete the following sentence. In a rectangle, opposite sides are... Okay, I've got to draw this to see this. So this side is opposite to this side. So opposite sides are parallel. Adjacent sides, this is a fancy math word for that they're touching. So that means, let me change colors here. That means like this line is adjacent to or touching this one and this one. So that's going to make a 90-degree angle, which means that they are perpendicular. Let's see if I can spell it right. There we go. All right. For a what percent or per hundred of the rectangle is shaded. So let's see how many we have. We're going to have to figure out what our fraction is before we figure out what our percent is. And we know that our fraction is part over whole. So how many wholes do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have a total of 10. That's going to be great because that makes it kind of easy to get to 100. And then how many shaded? So I have 1, 2, 3. So I have 3/10. And what I can do is I can say, all right, 3/10 is equal to what over 100? What do I have to multiply 10 by to get 100? And I multiply by 10. That makes this 30, which is 30%. And that's A. What percent of the rectangle is not shaded? All right, we can figure this out several different ways. We know that there are 7 out of 10 that are not shaded. And we can do the same thing we did with 3 out of 10. We know that this is times 10 times 10, and that's 70, or 70%. You can also take 100%, subtract 30, and get 70%. So there's a couple different ways to answer that problem. Let me change. Here we go. Right, 3 2/3 is an improper fraction. Okay, so I'm going to take this over here to show my work. And when they ask me to make a mixed number into an improper fraction, I'm going to popcorn. So that's multiply, add. Multiply, add. 3 times 3 is 9, plus 2 is 11. And that's my answer. Okay, let me change colors again because it's kind of tight here. And if you need to pause this or rewatch it, feel free to do so. Number 6 says replace each circle with the proper comparison symbol. So they're looking for a greater than, less than, or equal to symbol in the circle. A says 2 minus 2. Well, that's 0, which looks an awful lot like my circle. There's 0. 2 divided by 2 is 1, so this is greater. And here I have 1/2 plus 1/2. Now when I add, I keep the bottom number, so 2. 1 plus 1 is 2, so this side is 1. Okay, there's my circle that I'm going to fill in. Lovely. 1/2 times 1/2, I multiply across the top and I get 1. I multiply across the bottom and I get 1/4, so I know that 1 is greater than 1/4. If you can see my little alligator teeth there. Number 7. Point M represents what mixed number on the number line. So let's see how many spaces we have between 9 and 10. So I have 1, 2, 3, 4, 5, and then 6. So each of these is 1/6. So 1/6, 2/6, which can be reduced, 3/6, which can be reduced, 4/6, 5/6. So M is going to be 9 and 5/6. All right. Number 8, draw and shade circles to show 1 3/5 is equal to 8/5. So I have 1, and then I need to make this into 5. This is going to be a little awkward because it's not pretty. 1, 2, 3, 4, 4, 5. Oh, that's just beautiful. Okay, great. So this is going to be shaded, and then I have 3 of these little pieces of the pie that are going to be shaded. And that equals, let's see if I can make a beautiful drawing again. Dun dun. 1, 2, 3, 4, 5. Those are not equal parts, y'all. Just FYI. If you can make it more beautiful. 1, 2, 3, 4, 5. Okay. So 8/5. So this is 1, 2, 3, 4, 5, 6, 7, 8. And you'll see they are the same thing. Number 9, single digit numbers that are divisors or divisors of 420. And I went ahead and dropped this divisibility rules here. The chart is in your book. I don't remember what page it's on, but let's see what we can find out. So 420, if the last digit is 0, it's divisible by 2. The sum is going to be 6. This is the sum. So it's divisible by 3. If it's divisible by 2 and 3, it's divisible by 6. If the last 2 digits are divisible by 4, so last 2 digits are 20, that is divisible by 4. Ends in a 0, divisible by 5. 7, it is divisible by 7, but I just know that. I'm not sure what this cross off last number, double, subtract, repeat. No, I'm just going to divide it. 7 times 6 is 42. So that checks it, becomes 60. So this is 7. 8, if the last 3, I don't know. Let's see. There are only 3 digits. So 8 goes into that. 5 times with 40. That's not going to fly. 9, if the sum is divisible by 2, that's not going to fly. And then these are all double digits, and it just says single digits. So this is going to be our answer. You can kind of see how that's a trial and error right there. It takes a little bit of doing. Number 16, arrange these fractions in order from least to greatest. What I'm going to do is I'm going to find a common denominator. And that's the bottom number. And that's going to help me to compare these fractions. Now you may be able to look at these and say, well, yeah, this is bigger than that, but sometimes it gets a little confusing. So I'm going to use the 16 as my common denominator. So this is going to remain the same. Okay, so 1/2 times 8 over 8 is equal to 8 over 16. So that's going to be 8 over 16. And then let's do 3/8. 3. Oh, where'd my thing go? I just wrote on something different. Okay. 3/8 times 2 over 2, because 8 times 2 is 16. 6 over 16. So that's going to be here. And then 3/4. 3/4. So 4 times what gives me 16? 12/16. So when I look at these numbers and I go from least to greatest, I have 1/16, 6/16, 8/16, and 12/16. But that's not my original number. So let's go and plug in our original number. 6/16 is 3/8. 8/16 is 1/2, and then 3/4. Little bit of a problem, little bit of a long problem there, but lots of good skills. Okay, so we've got a lot going on this page. What I'm going to end up doing is I'm going to end up using, let's see if it'll let me draw. I'm going to end up using this space over here on this side, and when that gets full, I'll stop and I'll erase it and we'll start over. So I want to make sure that you can see all of the work that goes into each one of these problems so you understand how they are solved. So 24 is 2 2/3, and you guys know that I like to put these vertically. If you like them horizontally, that's fine. You don't have to do it my way. So when we're adding fractions, we know that the denominator, remains the same. The 3 is going to remain the same. 2 plus 2 is 4, and then 2 plus 2 is 4. So then I have to take care of this issue here, and I get 1 1/3. Now this is one of those difficult ones where I need to add this back to the whole number. So I have 5 1/3 as my answer. Okay. If you're having trouble with those, I highly suggest writing down every single step. 25 is 2/3 times 2/3 times 2/3. So when we multiply across the top. 2 times 2 times 2. and we multiply across the bottom. 3 times 3 times 3. 2 times 2 is 4, times 2 is 8. 3 times 3 is 9, times 3 is 27. That's my answer. Let's take a look at 26. Describe each figure as a line, a ray, or a segment, and then use a symbol and letters to name each figure. This is great. So a ray starts at a certain place and then goes on forever. So this is a ray, and when we name the ray, we always start with the spot that it starts. Okay, so we're going to draw a little mini ray MC. This is not ray CM. If it were ray CM, it would have to start at C and go forever in the M direction. So this is my answer here. Okay, let me change colors. All right, B, it goes on forever in both directions. So this is a line. And with a line, we're going to draw a little mini line, and we have line, and we can say it either way. It doesn't matter because it goes on and, oh, sorry, that was supposed to be, let's try that again. Because it goes on forever in both directions. Okay, so both of those are acceptable. Okay. And then this is a segment because it stops at the end of each one. Okay, so you can call this segment FH, and you'll see the little mini segment I have up there, or HF. Okay, let me stop and do some erasing. All right, so when we see this, how many 5/9 are in 1? We do the reciprocal. We flip it. So it's going to be 9/5 as our answer. And that's because 9/5 times 5/9 is equal to 1. 28. What are the next three numbers in this sequence? So 32 divided by 2 is 16. Divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. So the rule is to divide by 2. So 2 divided by 2 is 1, 1/2, and then 1/4. Okay. 29. Which of these numbers is not an integer? So we know an integer does not include fractions. This is going to be the only one that's not an integer. Integers don't include fractions or decimals. Everything is a complete whole number. Although it's not a whole, well, never mind. Integers don't include fractions and decimals. In the last problem, 30a, it says if a minus b is 5, what does b minus a equal? Well, we know when we flip the order, we flip the sign. So if this is positive 5, when we flip the order, this is negative 5. If w over x equals 3, or 3 over 1, what does x over w? So we're flipping this, we're getting the reciprocal, and this is going to be 1/3. How are wx and xw related? So 3 over 1 is the reciprocal of 1/3. And that's all we have for today. Feel free to ask me questions about any of this. We kind of went fast towards the end, and hope you have a great day.